said, don't forget your calculators. Kids, you gotta have one. Please make sure you bring your calculators. If you don't bring one next time, so that you can review fully with us, you'll have to rent one. I'm not gonna make you rent one today, but you'll have to next time, because you need to know how to press the buttons on the calculator so that you can get the right answers to the questions. Do not set yourself up for failure. Let's be prepared. All right, so I'm on page 14, and we are going to do the box problem. This is a guaranteed test question, and it's a guaranteed exam question. This is a big, big deal in pre-calculus land. Good news is we've done it before. Better news is it's easy. Okay? So here we go. We have a piece of paper.
You want that?
I am on 14D. We've already done F and G. We did F and G in my living room.
Oh, yeah, you're right.
We're doing D and E now. Okay? D and E. Okay? And actually, I don't think that we have done this before. I think I skipped this. All right, here's what I want you to do. I want you to grab a sheet of notebook paper. If you need a piece of paper, come up and get one. Get off your rear end and pick one up.
We come back and forth.
I mean, there is lazy, and then there is like, oh, and it's lazy.
Like we're on 1 point something.
All right, so everybody's got a piece of paper. Here's what I want you to do. We don't have a lot of time to spend on this, so we're going to do this quickly. We're going to take everybody's got a regular sheet of paper, right? Pretty much the same size. Even if you have notebook paper, it's pretty much the same size. All right, I want you to tear a corner, a square out of the corner. However big you want. I want you to tear a square corner out, whatever size you want. All right? And then as soon as you get, it doesn't have to be perfect, we're not using rulers and scissors and everything. As soon as you have that square, tear one the same size or as close as you can get out of all of the corners. So you're going to tear 4 corners out of this piece of paper. Okay? So you're tearing a corner off of each corner of your paper. So you should end up with something that looks like this. But your corners will be different than mine, and that's fine. That's what makes the problem interesting. Okay? So we got it, something that looks like this. Now, once you get all the corners ripped out, fold up these flats. See, these things are like flats. Fold them up. And when you do that, you're going to have a box.
Wait, can you go back? Replay?
No. Just do the best you can.
How do you do that?
So you literally just fold them. You take the corners out and then fold up the sides.
Literally just folding.
Yeah. Now, here's the very interesting thing. We all started with the same size paper.
We did.
But look, my box is different than Katie's box. My box is very different than Gaz's box.
Yours is good. Mine's more bitter though.
It's different than William's. Oh, look, it's different than, look at this one. See? Now, how come, all right, let's think about this for a minute. If I were a really nice teacher, and I had come today with a huge bag of M&Ms, and I walked around and I filled your boxes with M&Ms, would all the boxes hold exactly the same number of M&Ms?
No.
No. Because they're different sizes, right? They have different volumes. What made his box different than my box? We had the same size paper.
You scored different squares.
Exactly. So William, that is one of the classic pre-calculus problems. We have a piece of paper that we know is 12 by 14 big they need to be so that the box will hold the most M&Ms.
Wait, you have to figure out
How big the corners are to make it hold the biggest amount of M&Ms, okay? Okay, well, we'll see. Now, here's how we do this, guys. Listen. First of all, we write an equation for the volume of the box. Now, it's a box, what we call a rectangular solid. How do we find the volume of a rectangular solid? Who remembers the formula? Easy. A box. Volume of a box.
it's supposed to be. But it's like
Length times width times height. So your volume is length times width times height.
we write that on in here.
Now, well, no, that isn't the answer yet. That's the formula we're going to use. Now, for our box, the original length was 14. But we cut an X off here. Remember, you cut that off. And you cut an X off up here. So how long is it now? It's not 14 anymore. It's 14 minus 2X. Because this is the volume, this is the equation. We're working on the equation for the volume of the box. It's 14 minus 2X. That's the length. Now what about the width? Now it was 12 to start with, but you took this X off and this X off. So how wide is it now?
10.
No.
12 minus
12 minus 2X. You had 12 and you took out an X and an X. Now, when you folded up the flaps, this became the height, right? This became the height of the box. So when you fold this up, isn't this going to be the height? Well, how long is that? X. So your height is X. There is your equation for the volume of the box. Now listen to me, peeps. Listen. Every time you do a box problem, and remember, there's one on the test, there's one on the exam. Every time you do one, it's going to be one dimension minus 2x, the other dimension minus 2x and x. So if this paper had been 16 by 20, it would be 16 minus 2x, 20 minus 2x, and x. That never changes. Okay? Now, next question says, what's the domain? Now, domain, remember, deals with x, right? So I want you to think about how big can x be? You are going to set your domain, you're going to put x in between two numbers. You're going to say, okay, the lower limit for it is this, and the upper limit for it is this. Now, think about it. X stands for the size of this corner. Where's my box? I don't have my box. Anyway, X stands for the corner. Oh, I feel like X stands for the corner of the box, right? So can X be negative 10? No, because X can't be negative, right? That doesn't even make sense. So the lower limit on your domain is going to be 0. You have to be positive. You can't rip off a negative corner. Now, think about this piece of paper. Remember, how big was it to start? 12 by 14. Okay, so I'm going to take an X off this side and an X off this side. Can X be 20? Can I take 20 off here and 20 off here? No, I only have 12, right? Okay, well, wait a minute. How much can I take off then? I could certainly take off 2. Could I take off 3? Yeah. Could I take off 4? Yeah. Can I take off 10? No. No. I can't take off 10. Because If I only have 12, I can't take 10 off each side. Remember, you're taking it off each side. So what's the most I can take off each side if I only have 12? 5? Can I take off 5 and a half? Yeah. I can take off anything up until what number? 6. 6 is your upper limit. People, put your thinking caps on. You only have 12 inches. If you start ripping off both sides, 6 would be the most, because if you took 6 off this side and 6 off this side, you'd have nothing left, right? You certainly can't take off more than 6. This will always look like this. That will always be 0 because you can't be negative ever. And this number will always be half the smaller dimension. Whatever the smaller dimension is, in this case 12, your domain is going to be half of that. The upper bound of your domain. It's going to be half of that every time.
So if that was, if he says that 12 is all going to be half that,
The
what's that
smaller
called?
dimension. You're going to be half the smaller dimension. The paper's 12 by 14.
So if that
12
14
is the smaller number.
So if that 14 was a 6, it'd be 3.
Yep. It's half the smaller dimension. Okay? Now, the next question, final question says find the maximum volume. So we're going to use our calculators, but I need everybody to focus on this really important step. First thing I want you to do is go to your window. Because if you just graph this equation, you could come up with an answer that doesn't make sense. You must graph it in this window. So x min is going to be 0, and x max is going to be 6. So whatever you set up as your domain, that is going to be your x min and max in your window.
For the rest of the walk of
Just time out. Now, y min. Y represents the volume. What is the smallest volume that your box could have? Could your box have negative 200 cubic inches? No. What's the smallest the box can have? 1? Can it be a half?
0.5.
Can it be 0.5? Can it be 0.25? Greater than 0. So y min is always going to be 0. Volume cannot be negative. Now, y max is actually going to be the answer to the problem. Maximum volume, maximum y. So right now I have no idea, so I'm going to take a guess. I'm just going to set it at 200. Now that number's either going to work or it's not, and if it doesn't, we'll just change it. Alright? Here's what I mean by does it work or not. Let's type in our equation. So go to y equals, and type in this equation exactly as it is. So parentheses, 14 minus 2x, parentheses, 12 minus 2x, and x. So you're typing it in just like this. You don't have to multiply it out. Someday, most of you are going to be calculus students. And when you're in calculus, you'll learn how to do this problem by hand without a calculator, and then you will have to multiply it out. But for our calculator, that's fine. Just leave it just like this, hit graph. Now, what you need to see, it isn't a parabola, it's something that looks like this. What you need to see is that point right there. Can you see the top of the hill? Is it visible? Yeah. So back here, when I guessed this number, it was a good guess because it gave me the top of the hill. If I would have only guessed 100, I wouldn't have seen the top of the hill. And I would have had to change it, so I did.
So you always guess super high or something?
You always guess something, yeah.
Super high?
Well, I don't know if 200 is super high, but yeah, you want to guess something in the hundreds.
So 900?
Guess 900. You'll be fine if you guess 900. It's just this will be a little flatter. But 900 will be fine. All right. So now I'm going to find that point. So here we go. Second calc. Go down to maximum, because that's what we want, the highest point. Then you got to set the whole left bound, right bound thing. So I see Claire clicking on her arrows there, moving that left bound and right bound. Then set it up there in the middle, take a guess, and you should come up with 2.148, 160.584. When you do max or min, you get a point. You see it down there on the calculator? It says x equals y equals. Second calc. See, just like when you count zeros, Jada. This is with you. Second calc. And then you set your left bound and right bound. Did you set your left bound and right bound? Just exactly where you find the zeros. Get it over there to the side. All right. Set it to the right. I hope you make it. I hope you got the point in the center. I don't know. Hit enter. And then in between them. And hit enter. Okay? It should have given you the maximum.
Oh, yeah.
Yeah. So, Chase, we did all this before. You need to stay focused. All right? All of you do. You got to remember something for more than a day at a time, people. We can't keep relearning every day. This is just exactly what we did before. Only now we're finding the maximum instead of the zeros. Before we were doing zeros. Max, min, zeros, intersect, it's all the same. Procedurally.
Guess.
I made it up. I made it up. It's a guess. You have to guess. There's nothing in the problem to tell you have to guess. So 300 would have worked, 500 would have worked, they're all fine. You just got to see a hill. The key is you got to see the hill. So then you do your second calc maximum, and you come up with this point. Now, you have to answer the question. So you got to decide, is the answer going to be the 2.1 number, or is the answer going to be the 160 number? What is your thought on that? This is the maximum volume, because when I set my problem up, and that would be cubic inches, always put a unit on it. When I set my problem up, y represented the volume, and x represented the size of the corners. So Jada, if you wanted your box to hold the absolute most, if your paper was 12 by 14, which it wasn't, your paper's not that big, but if it were 12 by 14, this is the size of corners that you would want to cut out. This tells you how big the corners should be. This tells you what your actual biggest volume is. All right, let's try another one. There's another one, just the same. Paper's different size, but our strategy will be exactly the same thing. All right, so anybody have a wild guess what the equation for my volume will be? I hear something, but I can't make it out. What do you think that equation's going to be?
B equals 20 minus 2x. And then 24 minus 2x.
Okay, so Jada was listening because I promised you that the equation for your volume was always going to look exactly the same. The only thing that will change in that equation is the numbers, and that depends on how big the paper is. Now, because the numbers are different, your domain's going to be different. What is X gonna be between for this piece of paper? 0 and what? 10. Always have the smallest dimension, right? 0 to 10. So this is gonna be my X min, and this is gonna be my X max. What did I tell you Y min always is? 0. Now, let's leave Y max at 200. It's not gonna work this time, but I want you to see what happens when it doesn't work. So type in your new equation.
Why wouldn't it work?
You'll see in a minute. Type in your new equation, which is 20 minus 2x, 24 minus 2x, and x. Biggest mistake that's made, kids forget to type in the new equation. Type in the new equation. Window, x min 0, x max 10, hit graph. William, what happens when I hit graph? I see it going up, and I see it coming down, but what do I not see? Highest point. What am I looking for? The highest point. So now I'm going to go back and I'm going to change this to what?
600.
600. So window, change Y max to 600. Hit graph. Is that big enough? Nope. Get closer, but not big enough. Let's go with 1,000. I'm just going to go with 1,000.
I thought you said ours would be in the hundreds.
1,000 is 10 hundredths. Yeah.
I didn't know.
900 will work. 1,000 works, and I get my same kind of picture. I see a hill. This number right here, kids, can be lots of different things. It just has to be big enough to see the top of the hill. Okay? So I used 1,000, she used 900, somebody else used 1,100, who knows? As long as you can see the top of the hill. Once you see it, second calc, go down to maximum, set your left bound. Remember, you're looking for the top of the hill, so your left bound is over here and your right bound is over here. Or for those of you with new calculators, you get a line. Lines are like that. And then in between them, who got a maximum that you're willing to share?
3.6214896.
Okay.
And then 774.164.
Be 165, I think.
Yeah, around that.
Yeah. Perfect. Thank you, Gabe. Perfect. Now, was the question the same? Find the maximum volume. So what do we write in the answer blank for question C? 774.165 cubic inches. This is question B. This is question A. A is the equation, B is the domain, C is the, in this case, the maximum volume. You could also be asked for how big X is, how big the corners are. And if you were asked how big the corners are, it would be 3.621 inches. All right, now we're down to H, because we already did F and G, so now we're going down to problem H, which is what we call a mixture problem. You've done these before, back with Mrs. Field and Miss Ludington. I'm not sure how they did it. They may have had you set up a chart or something. I'm not going to. I'm going to show you how it will always work real easily. So if you're paying attention and you spend a little time studying, you'll have no problem with these problems.
When's the test? When?
right after we get back from all these days off. All right, so write this down for problem number H. Write this down. Anytime you are making a mixture, so
Those N's or N's?
it says amount times percent plus amount times percent equals amount times percent. So, look at the problem, read the problem. Would you agree that we have two different things that we're mixing together to get a final product?
Yes.
Okay. So we're going to take the amount times the percent of the first thing, the amount times the percent of the second thing, and that's going to equal the amount times the percent of the final mixture. Now here's the really good news. 4 of those parentheses, there's 6 altogether, 4 of them are right there in the problem. 4 of them are just there to plug in. So we have 12% lemonade, 0.12, 12%. We have 20% lemonade, and then we have 18% lemonade. You cannot miss that. The numbers are right there. Now the other number that's in the problem is 18 gallons. Now that's an amount. That's not a percent, that's 18 gallons. That 18 gallons goes with the 20%. So I'm going to put 18 there. The question says, how much? 12%. So I'm going to call this amount X. That's how much. I don't know. I need to figure that out. Would you agree with me?
Yeah.
The only one I don't have filled in is this one. So I have to use my brain a little bit. Let's think about this. This is the final amount, the total amount that I get when I mix X gallons with 18 gallons. How many gallons will I have if I mix X and 18 together? 18, not 18 times X, 18 plus X. Right? Think about it, if you put 5 gallons and 4 gallons together, isn't that 9? That's not 20, that's 9, you add. Okay, so now, I don't need my graphing calculator, any calculator will work, but since I'm only allowed to use a graphing calculator, I'm going to do it. Here we go. 0.12x plus, I'm going to multiply these two together. Whoops. I'm going to distribute here. This is a distribute. So I'm letting my calculator do all of the arithmetic. Now, how am I going to solve this? Regular equation. Move things around, yeah. So there's no like terms to combine, but I do need to get all the x's together. So I'm going to subtract 0.12x. I would highly recommend using your calculator, guys, because even though I know you can do that in your head, you are tempted to put 0.6 and it's 0.06. And of course that makes a big difference. So don't be ashamed to use your calculator, 0.18 minus 0.12, just to make sure you don't make a mistake. Then I gotta subtract this over to here, right? So again, I'm going to use my calculator so I don't risk any careless stuff. And then I'll divide. And always always put a unit on it, so it would be 6 gallons. Yep. Sign out. Hurry up. Okay. Now we have odd. Problem odd. Okay. Turn the page over. Yep, problem odd back there. This should be back at the last page of that packet of notes. Alright, so we have I, which is another problem just like the one we just did. So I'm going to start, I'm going to erase this. And I'm going to start with the same exact framework. Anytime I am mixing these things together, I'm going to use this framework. Okay? So we've got 6 quantities here. I promise 4 of them are always going to be there, right there. Just plug them in. So what are the 4 we've got? We got 22% sugar. We got 74% sugar. And we have 50% sugar. Would everybody agree that I have the right percentages in the right places? Everybody's okay with that?
What do we mess up with 74 first?
It wouldn't mess up, but you won't answer the question, because the question is how much 22, so I want to put my X right there with the 22. Because how much, that's X, that's what I'm looking for. What about the 100 that's in the problem? That's 100 gallons. That's an amount. It goes right here, doesn't it?
Yep.
So when you've got this extra number, put it with the right percentage. Make sure you get it with the right percentage. Now, a minute ago when we did this, I forget what they all were, but we had something that looked like this. For the last one we did, I don't know what the percentages were, but we put an X there, and we put like an 18 here, and then this was 18 plus X. Remember that? Because this was the total, right? Well, this time it's a little different because this time I know what the total is. So this isn't going to be 100 plus X. That doesn't make any sense.
100 minus X.
Bingo! 100 minus X. Very good. If the empty parentheses is at the end, like it was in the last problem, it's 100 plus X, or 18 plus X, or whatever, 52 plus X, whatever it is plus X. If the empty parentheses is in one of these spots, which will always be this one, it's 100 minus X, or 18 minus X, or 53 minus X. So this spot is the plus X spot, and this spot is always the minus X spot. And then everything's the same. So 0.22X plus, here's your distributive this time. There's always going to be something that needs distributed. So 74 minus 0.74X. This time, William, we do need to collect like terms. Do you see that? They're on the same side of the equation.
Yep.
So we're going to add those together. Sign back in, please. And we're going to use our calculator to make sure we don't make a mistake. So negative 0.52X. So now I'll subtract 74. And again, please use your calculator if you don't trust your arithmetic. And then I'll divide. And this time, I got 46.15 gallons.
Is this business people do?
What?
Business people do this?
Sure. One of the best examples I can think of, you ever eat trail mix? Okay, you know that's a bunch of different things mixed together, right? And they all cost different things. So let's say you're making your trail mix and you're putting in pretzels and peanuts and M&Ms. So you would have the amount of pretzels times the price of pretzels, the amount of M&Ms times the price of M&Ms, the amount of peanuts times the price of peanuts. You'd have three things, and then all added up to however much trail mix, and you know how much to charge for it then. Okay? All right. We are going to just cross off the last two. We're going to have to start cutting some stuff. We're so dang far behind. So no fault of yours. I mean, it's just the way the schedule and everything is. So we're not going to do those. We're going to be done. So our notes are now finished. Already. Hang on to them though, because 2.1 starts at the bottom of them, and we'll need that. Your 1.7 homework will be due on October 27th. That is the next time that I see you. 1.7.
Is this 1.7?
Yes, we just finished. We just finished 1.7. Okay? 1.6 is due tomorrow, I believe. I think that's what I said, but.
So that basket we can turn it into?
Yep, the basket's right down, yep, it's due tomorrow. Yeah, the basket's still out in the hallway,
Alright.
and that's where you'll put it, or you'll bring it by here tomorrow, you can hand it to me either way. We're not done though, we're not done, okay? We still have some time, we're gonna practice a little bit. Clear on expectations, 1.6 tomorrow. Remember, that's the last day you're gonna be in school for a while. So don't think, oh, well, I'll just turn it in Monday. No, Tuesday, no, next week, no, next Monday, no. It's gonna have to be October 27th. That makes it really late. So please get 1.6 done and turn it in to me tomorrow, either personally or in the box down here. Now, let's do a couple graph problems just to check to be sure everybody is on target.
We go to the one on the homework.
So we can do a homework one, or we can do that graph practice sheet that I just gave you. I'll do one homework one, because I'm not going to stand here and do all of your homework for you. But I'll do one or two homework ones, and then we'll go to our graph practice sheet that I just gave you.
Yeah, the last two homework.
William, you need to calm down a little bit, and I'll do one for you, but then I'm going to do one for someone else too, okay? So, William, you want to do 1, 2, 3, 4, or 5?
4. The graphic.
4. All right, we're going to do 4. So I'm going to start with my original picture. Always start with the original, which looks like this.
Pardon?
4 or 5.
We're doing crap.
No, I am doing a homework problem. And then I'm going to do graph practice if I have time. But I'm starting with a homework problem. There is the given picture, and William has asked me to do number 4, which is this. So number 4 has a coefficient out in front of it right here. What does a number out in front do? No, it's not a move up or down.
Oh, it's not.
It makes it multiplies the height. It makes it taller. So this multiplies the height or the y's. So look at your original triangle there in the center. This thing right here, part of the triangle anyway. How tall is he? 3. So now he's going to be 6. So that point, 1, 2, 3, 4, 5, 6, is going to be clear up here. Now, this point is 1 height. You're doubling it, so now he's going to be at 2. All the y's are getting multiplied by 2. This one isn't moving. Kids, his y is 0. 0 times 2 is still 0. That one isn't moving. It's a 0. Now what about this triangle here? How far down is that? That's down 2. So he's going to be all the way down 4 now. So there would be the answer to the question. Notice it's in exactly the same place. I didn't move it. There's no moving going on. It's just stretched. A number out in front impacts the height of the picture. So it either stretches it or it shrinks it, depending on the number. Okay? Now, one more from someone else. Who else has one you would like me to do? Cammy? Number 2. Number 2 has 2 things going on. All right? So number 2 is going to take the whole picture and do what with it? What does this x plus 3 in parentheses do? Left. Left. So this is going left 3. Now, what is that guy doing? Down 1. I cannot do this in one step. I'm going to do it in 2. So I start in the parentheses, left 3. So go back to the original problem. And every single point goes left 3. I don't care where you start, they all go left 3. So 1, 2, 3, 4. This one right now is at negative 4. The beginning of the picture is at negative 4. So now he's going to be back at 1, 2, 3, 4, 5, 6, negative 7. And then my triangles right there. Now I got to draw that little thing, whatever that is. So it's going to look like this. I somehow got it drawn on there, just extend it out a little bit. And then it's going to go up. So actually, the end point is now at the origin, right? Because it went right 3. Or left 3, I mean left, 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 left. So there's the picture, left 3. Now I still have to go down 1. So right there on your boxes, just take each of these points you just graphed and go down 1. So you're going to have exactly the same picture. It just drops down 1. Yep. This is at negative 3, yep.
Number 5.
Nope. You get in here before school tomorrow. What we're gonna do now is something from the graph practice, and that might help you do number 5. So it looks like number 5 has a negative inside the parentheses. Oh, look, on graph practice 1, problem 4 has a negative inside the parentheses, which is like number 5 on your homework. All right, so what's the shape? We're on graph practice 1, which I handed out to you just earlier today. It's called graph practice 1. It's stapled to graph practice 2. So it's kind of hard to see, but you gotta count the boxes here. So it looks like 1, 2, 3. All right, so I've got a big triangle and a little triangle, and then I've got a very long trapezoid. Okay. So I'm going to just randomly do number 4 since some of you had a question about that in the homework. So number 4 says f of negative x. I don't care what your shape is. It doesn't matter what the shape is. When you put a negative on the x, inside on the x, what happens to it?
Flip sideways.
Flip sideways. That's a sideways flip. Guys, negatives are flips. When it's inside like that, it's sideways. When it's out in front, it's upside down. Negatives are flips. So, that means that whatever's on this side is going over there. So that triangle is going over, and so is the little triangle. Oh wait, did that go up 3? Yep, sorry about that. And then that is coming over here. So that is actually the answer to graph practice 1, number 4. Now in the homework, you have that situation, but then wasn't there a number on the end of it too? In the homework? So what would you do if there's a number on the end of it? Move it up or down, depending on if it's plus or minus. But you would do this first, which is a sideways flip, and then you would go up or down, whatever that number is that's on here. Okay? Well, I would love to say we